Okay, my third grade friends, here's part 2 of our lesson for this week. So in the last lesson, we talked about fractions that can be equal to 1, and we learned that any fraction where the numerator and the denominator are the same magically are equal to 1. So this is just a reminder. The denominator always tells us how many parts make up just one whole. So for example, I have a figure here. It has 8 parts in all, so the denominator is 8. Regardless of how much I shade in, the denominator will be 8. Regardless of how many circles I have exactly like this, the denominator will still be 8 because the whole is broken up into 8 equal parts. Write that down. So sometimes we're going to have a model that has more than one model in it, so it has to represent more than one whole. For example, here I've got 2 of the exact same rectangle. The denominator still has to tell me how many parts are in just one whole. So if I look at this, my initial instinct, and I know a lot of your initial instinct, is to say there's 1, 2, 3, 4, 5, 6, 7, 8 parts altogether, denominator's 8. That's not true, because that's how many parts make up 2 wholes. I need to know, to decide my denominator, how many parts make up 1 whole. 1, 2, 3, 4. One rectangle is 4 parts. Now, the numerator is going to tell me how many parts are shaded all together. And the fraction's going to look crazy because there's 1, 2, 3, 4, 5 parts all together. Now, all of a sudden, we've got fractions that have numerators that are greater than denominators. That can be tricky. That has a special word. It's called improper. And that's just because it looks like it's upside down. It's not, though. And I want to be clear, 4/5 and 5/4 are not the same thing. These are not equal. So you can't just flip it around and write it the other way. Even though this looks wrong, it's actually correct. Because the denominator tells me how many parts are in one whole. 1, 2, 3, 4. And how many total are shaded, which is 5. Let's practice. So here I've got the exact same whole. Let's imagine we're having a party. Woohoo, a party. And I ordered pizza. And I ordered 3 pizzas. This is pizza 1. This is pizza 2. And this is pizza 3. I invited people to my party, and the pink ones, the shaded ones, that's how much pizza we ate. The pizza, regardless of how many I've bought, how many are shaded, the pizza is cut into 8 equal parts. This one has 8 parts. 1, 2, 3, 4, 5, 6, 7, 8. This one has 8 parts, and this one has 8 parts. They all have 8 parts. It doesn't mean my denominator is 24. That is not what it means. It means the denominator is 8 because one whole pizza is cut into 8 slices. Now, how many parts are shaded? How much pizza did we eat? Well, we ate 8 from this one. We ate 8/8 of that pizza because that's one whole pizza. We ate 8/8 of this one because that's another whole pizza. And we ate 1, 2, 3. 3/8 of this pizza. So in all, we ate 8, 16, 19/8 of the pizzas. We didn't eat 6/8. That's this part. Looks funny because it looks like it's upside down. The reason it looks like it's upside down is because 19/8 is greater than 1. Fractions are improper when they are greater than 1. Here's another one. Okay, it's not pizza anymore because it's not shaped like pizza. Now it's a Twix bar. So I've got 1, 2, 3, 4, 5 Twix bars. Each of the Twix bars are all broken into thirds because there are 3 parts in one Twix bar. One Twix bar has 3 parts, so that has to be the denominator. Now, how many parts are shaded? Let's say the shaded parts are the parts I ate when I was feeling hangry the other day. I ate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 thirds. That's a lot of Twix bars. We'll pretend they're fun size. It's not any better though. 14 thirds. 14 thirds looks upside down. It's improper. That's because it is greater than 1. Because 1 is 3 thirds. And if I add 3 thirds plus 3 thirds plus 3 thirds plus 3 thirds plus this 2 thirds, that's going to equal 14 thirds. These fractions are greater than 1 because it's more than one figure. Here's another one. Let's call this one brownies. After we ate the pizza at the party, we had brownies. I baked 3 pans of brownies. Each pan had 6 brownies in it. See? 1, 2, 3, 4, 5, 6. There's 6 brownies in one hole. We ate the shaded ones. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. We ate 6 plus 6 is 12. Plus 3 is 15. We ate 15 sixths. 15 sixths looks upside down. Numerator is greater than the denominator, so it's greater than 1. Here's another one. I can't think of a fun food to make this because it's triangular. And I, right now, at 11 o'clock at night, cannot figure out any triangular foods. So, I don't know what this is, but this is what we've got. We've got 6 of them, and they are cut into halves because they all are broken into 2 equal parts. One whole triangle is broken into 2 equal parts, so that's the denominator. How many parts are shaded? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 halves. 11 halves of whatever kind of crazy food that is. And 11 halves is greater than 1. Okay, you are going to practice that now. Remember, the denominator is the number of parts in one whole, not in all the holes combined. That's the mistake that people are making a lot of. So please don't make that mistake. Go practice and then come back for video number 3.